So here's day 12, sequences and series. So here we're looking at some different sequences and series and asking which is an arithmetic sequence. Okay, well these are all series. These two are series because we're adding or subtracting them. These ones are sequences. This one goes 3, then 3, then 3. So A is definitely an arithmetic sequence. -3 to 4 is 7, and then 4 to -5 is -9, so that's definitely not an arithmetic sequence, so that would just be A. An arithmetic series, well, it could be this, 4 plus 8. The difference between these terms, let's see, is 4 and then 8 and then 16, so that's not arithmetic. The difference between these, 8 and 2 is -6. 2 and 12 is -10. 12 and 22 is -10. 8 and 2. Let's see. This is close. 8, -2, -12, -22. Yeah, this is -10. This is -10. This is -10. So an arithmetic series would be D. Geometric series would be B because 4 times 2 is 8 times 2 is 16 times 2 is 32. These equivalences don't really make sense anymore, but we're multiplying by 2 each time and then adding them together. Calculate the sum, I equals 1 to 1,000 of I. So this is asking us to add the first 1,000 integers. And remember that it is n divided by 2 times n plus 1, so that would simply be 500, where n is 1,000, times 1,001, which is 500,500. 55 says, is the following sequence convergent or divergent? If it converges, find the value. So this, we're wondering if what happens as n approaches infinity of 2n squared plus 1 all over 3n minus 7. One thing you can do is divide every single term by the highest power of n, and that kind of helps to understand it. So that would be the limit as n approaches infinity of 2 plus 1 over n squared divided by 3 over n minus 7 over n squared. So this goes to 0, this goes to 0, this goes to 0, that goes to 2. So if you're approaching 2 over something that's heading towards 0, this is getting infinitely large. So that's going to head towards infinity and be divergent. You'll notice that if you've got a higher power in the numerator than you do in the denominator, it's going to outgrow the denominator and you'll get something that gets really large. 56 is asking us to calculate the sum from j equals 15 to 55 of 9j plus 10. So 9j plus 10 is it's an arithmetic sequence. The first term would be plugging in 15, so that would be 9 times 15 plus 10, which is 90 plus 45, 145 total, I think. 90 plus 45, 135, 145, so that would be our starting value. And we know that the sum, S sub n, is equal to n over 2 times a sub 1 plus a sub n. But this is a little bit confusing because we're starting at 15 and going to 55, so I'm not sure the n over 2 quite checks out here. Like n over 2 should be 55 minus 15 divided by 2, which should be 40 divided by 2, or 20, right? Because we only have 20 terms. So in this case, we kind of have to think of shifting it almost and saying, you know what, my first term is actually the 15th term, and my 20th term is actually the 55th, or my 40th rather. So we're really trying to find this going from 15 to 55. So that would be actually 40 divided by 2 because there are 40 terms. And then 145 plus an a sub n should be 9 times 55 plus 10. And that is 9 times 55, 495 plus 10, or 505. So that should be plus 505. And that gives me 145 plus 505 is that, times 20 should be 13,000. Hopefully that's right. 57. Okay, suppose a display of cans in a supermarket is built with one can on top, 2 cans in the next row, and 1 more can in each succeeding row. If there are 12 rows of cans, how many cans are in the display? Okay, so looking at the sequence, we've got 1, then 2, then 3, then 4, then 5, dot, dot, dot. So this is an arithmetic sequence of a sub n equals a sub 1, which is 1, plus n minus 1 times 1, because that's my constant difference of 1. I could also write this as just simply n, right, because that simplifies to n. And we know that the sum, we're trying to sum up the first 12 terms, so s sub 12 would be 12 divided by 2 times a sub 1 plus a sub n, which is simply 6 times 1 plus 12, which is 6 times 13, or 60 plus 18, or 78 cans. 200 cans are available to be displayed, how many rows are needed, and how many cans will be left over? So 200 is our sum now, and we're wondering which number of cans is going to give me that. So it should be n over 2 times, a sub 1 plus a sub n. Okay, but I don't know what a sub n is in this case, so say 200 equals n over 2 times a sub 1 plus, remember, a sub n is also n, right? So I can just put n. And a sub 1 was 1, so that's equal to n over 2 times 1 plus n. Multiplying by 2, I get 400 equals n plus n squared, or n squared plus n minus 400 equals 0. Now I can solve that on my calculator by graphing it. So I will do x squared plus x minus 400, and I'll graph that. Nothing shows up, so maybe I'll change my window to go from negative, not negative because these need to be positive, maybe 0 to 40, and then my y min will just leave. Okay. So there it's crossing, and I could do second calculate 0, left bound. Let's see here. I'm on the positive side right now. There it is. Negative side, positive side, guess. So it gives me 19.5. So that means I will need 19 rows. And now to figure out how many cans will be left over, I'd want to plug 19 in here and figure out how many I'm using. So that would be, let's see here, 19 divided by 2 times 1 plus 19, which is 20 times 9.5. That doesn't make sense. Whoops. 20 times 9.5, which is 190. So I'm using 190 cans, which means 10 cans will be left over. For 58, it says a series of k consecutive even integers begins with w. Write an expression for the last term in the series. So w, w plus 2, w plus 4, w plus 6 is my a series of k consecutive even integers, write an expression for the last term in this series. Well, if I'm adding, so I'm adding these because it's a series. So the last one would be the sum of k consecutive integers, and that would be k divided by 2 times a sub 1, which is w, plus a sub n, which should be w plus k minus 1 times 2, right? Because here we're adding 2, then 4, then 6. I could also write that as k over 2 times 2w plus 2k minus 2. Or if I actually divide everything by 2, I just get k times w plus k minus 1. Write an expression for the sum. Okay, so this is actually the sum. And the last term should simply be what I had here. It should be w plus k minus 1 times 2. So these should be swapped. '59 says, Alex writes, this is his first step in using the formula to find the sum of a given geometric series. Write the terms of the series he was given. Okay, so geometric series, recall, is S sub n equals n times 1 minus r to the n all over 1 minus r. No, not n, but rather a sub 1. So it looks like a sub 1 equals 6. Looks like we're finding with r equals 1/5, and we're finding the first 4 terms. So it looks like we've got 6 plus 6 times 1/5, which would be 6/5, plus 6 times 1/5 squared, which would be 6/25, and then 6 times 1/5 cubed, which would be 6 over 125. That would be the first 4 terms, and that's equal to the sum of 6 times 1/5 to the n minus 1 from n equals 1 to 4. Find the sum I equals 1 to 30 of a sub I for the sequence a sub 1 equals 28, a sub n equals a sub n minus 1 minus 4. So this is an arithmetic sequence where this is my constant difference, d equals -4, and this is a sub 1. So if I want to find the first 30 terms, that is s sub 30, and for arithmetic it should be 30 divided by 2 times a sub 1, which is 28, plus a sub n, but it's also, remember that the formula is either s sub n equals n over 2 times a sub 1 plus a sub n, or n over 2 times a sub 1 plus a sub 1 plus n minus 1 times d, because that is a sub n. So it should be 28 plus 28 plus 29 times -4. So that's 15 times 28 plus 28 plus 29 times -4 times -60, which is -900. And it makes sense that you'd have a negative sum because we're subtracting 4, and those are getting negative pretty quickly. 61 says the sum of the first 4 terms of a geometric sequence with a common ratio 3 is 300. Find an explicit formula for the nth term of the sequence. Sum of the first 4 terms. So that means that s sub 4 is equal to a sub 1 times 1 minus r to the 4th, but common ratio 3, so 3 to the 4th divided by 1 minus 3. And we know that this is 300, so 300 has to equal a sub 1 times 1 minus 3 to the 4th, all divided by -2. Solving this for a sub 1, we get -600 equals a sub 1 times 1 minus 3 to the fourth. So a sub 1 should be negative 600 divided by, let's see, 3 to the fourth is 81 if I'm not mistaken. So this should be divided by negative 80. So a sub 1 equals 600 divided by 80, which happens to be 7.5. So we could then write a sub n equals a sub 1 times r to the n minus 1. And that would be our explicit formula. Coming now to 62. Let's see how much more we got. All the way to 72. Okay, we got quite a bit. Coming down to 62, give an example of a geometric sequence with a common ratio 1. So how about a sub n equals 3 times 1 to the n minus 1, which is just 3. Explain why the formula for finding the sum of the first n terms of a geometric sequence cannot be applied to this sequence, because that is s sub n equals a sub 1 times 1 minus r to the n all over 1 minus r. And right there we would get 1 minus 1, which equals 0, and we'd be dividing by 0, which is undefined. So that's why this wouldn't apply. Give an expression for the sum of the first n terms of your answer to part A. Well, the first n terms, if your geometric sequence is just 3, would be 3n. Is that right? Yeah, 3 plus 3 plus 3 plus 3, dot dot dot, plus 3, and there are n terms, then that's just simply 3 times n. Suppose the 99th term of an arithmetic sequence is 200 and the 101st term is 38. Find the 100th term. So let's see, a sub 99 equals 200, a sub 100 equals question mark, a sub 101 equals 38. So what is the difference between 99 and 101? Well, 38 minus 200. So we're actually adding 162. Sorry, subtracting 162. So a sub 100 needs to be a sub 99 minus 162 over 2. We need to go half the distance, and that's 81. So it should be 200 minus 81, which should be 119. Right, that needs to be halfway in between the two. Evaluate n equals 1 to 5 of 2 to the n. So remember, this is a geometric series, and s sub n is going to be a sub 1 times 1 minus r to the n, all divided by 1 minus r. A sub 1 is just, well, if we plug in 1, we actually get 2. So that's going to be 2 times 1 minus r to the 5th. Yep. But r is 2, so 2 to the 5th, all divided by 1 minus 2. So that's going to be negative 2 times 1 minus 2 to the 5th. So 2 to the 5th is that. 1 minus 32 is negative 31 times negative 2 is 62. I just want to check that this works. So 2 to the 1st plus 2 squared plus 2 cubed plus 2 to the 4th plus 2 to the 5th. So if we add those up, we get 32 plus 16 plus 8 plus 4 plus 2, which is 62. So in fact, using the formula and doing it by hand, we do end up with the same thing. 2 to the n minus 3, well, this should be the same thing except subtract 3, so 59. 2 to the n minus 3, well, this is different because now we're summing from n equals 1 to 5 of 2 to the n, and then we are subtracting summing n equals 1 to 5 of 3. So this we already know is 62, and this is just adding 3 plus 3 plus 3 plus 3 plus 3. 1, 2, 3, 4, 5 threes. So that's just 5 times 3. and that's 15. So 62 minus 15 ends up being 52 minus 5, which is 47. Okay, I'll scoot that up. But the difference between this and this one is not in the part of the sum. It's just after you sum them up. So you can just sum them up and then subtract 3. This is part of the sum, so you have to sum up all of those 3's. Okay, plugging along here, 20 minutes in. Write the first 5 terms of this sequence. Well, t sub 1 is going to be 3 over 3 plus 35, 38. T sub 2 is going to be 9 over 9 plus 35, which is 44. T sub 3 is going to be 27 over 27 plus 35, which is 62. T sub 4 is going to be 81 over 81 plus 35, which is 116. And T sub 5 is going to be 243. Is that 3 to the 5th? 243 divided by 243 plus 35, which is equal to 278. It says, does T sub n converge or diverge? If it converges, state this limit. So it converges. If n gets really large, the 35 is barely going to matter. So the limit as n approaches infinity of 3 to the n over 3 to the n plus 35 is just going to equal 1, because these basically equal 1 as n gets super, super large. 66 says, does the series 1 plus 1 plus 1 plus 1 plus 1 converge? Explain your answer. No, of course not. It just heads towards infinity because you're just adding 1 a ton of times. (67) The sum of the first 15 terms of an arithmetic sequence is 825. The last term is 97 and the common difference is 6. Find a sub 1. So we know that s sub n is equal to n over 2 times a sub 1 plus a sub n. So the first 15 terms is 825, and that equals 15 divided by 2 times a sub 1 plus a sub n, which is 97. So solving this for a sub 1, we should get 825 divided by 7.5, which is 110 equals a sub 1 plus 97. So a sub 1 equals 13. Write a formula for a sub n. Well, a sub n should be the first term plus n minus 1 times the constant difference of 6. Write this scenario in sigma notation. Well, this would be the scenario in part A. That would be from n equals 1 to 15 of 13 plus n minus 1 times 6. We're summing up these terms from 1 to 15. Find the limit if it exists. No, these sequences never exist because they're heading toward infinity or negative infinity. The limit as n approaches infinity of 13 plus 6n minus 6 is infinity. So it does not exist because it's increasing without bound. Okay, same thing for the sum, right? The limit as n approaches infinity of s sub n also heads towards infinity. So it does not exist because we're just adding up terms that are getting bigger and bigger and bigger. Okay, coming over here, find the sum of the integers between 500 and 1000 that are divisible by 3. Oh dear. Well, we got to think about, is 500 divisible by 3? It's not. But 501 is. So 501 followed by 504 followed by 507 ... Right, these are all divisible by 3. 1000 divided by 3 No, but 999 divided by 3, yes. So it should go all the way up to 999. So this is an arithmetic series. So we want to figure out how many terms we have here. Let's see here. If I do 1,000 minus 500, there are, including 500 and 1,000, there are 501 numbers. 501 numbers between the two inclusive. And if I divide that by 3, well, let's see here. If I do 999 minus 501 plus 1, I get 499 that are actually between these two. Dividing that by 3, I get 166. Let's see, 166 times 3. Let's see here. So I'm curious if this is a sub 1 and this is a sub n, but a sub n should be a sub 1 plus n minus 1 times d, and the constant difference is 3. So this should be 501. 999 should be 501 plus n minus 1 times 3, and if I solve that for n, 999 minus 501 is that, divided by 3 is 166, plus 1 is 167. So there are 167 numbers. So now I can say I want S of 167, which should be 167 divided by 2 times a sub 1 plus a sub n. And that's 167 divided by 2 times 501 plus 999 is the sum 125,250. Okay. 69 says consider the sequence of dots in the rectangular array shown at right with Q1 equals 3. So this is 3, this is 8, this is 15, this is 6, this is 24. So you notice that this looks like n squared minus 1. So q sub 1, but it's actually n plus 1 squared minus 1. Because if I plug in 1, I want to get 4 minus 1. If I plug in 2, I want to get 9 minus 1. So explicit formula would be a sub n equals n plus 1 squared minus 1. What is q of 99? Well, q sub 99 would be 99 plus 1 squared minus 1, which is 100 squared minus 1. And 100 squared is 10,000. So minus 1 would be 9,999. 70 says, true or false, the harmonic sequence converges to 0. This is true. The limit as n approaches infinity of 1 over n definitely approaches 0 because 1 over n gets small as n gets large. 71, the sum of the first 7 terms of a geometric sequence with a common ratio of 1/7 is 57.166597. Write the scenario in sigma notation. Okay, the sum from I equals 1 to 7 of whatever a sub 1 is times 1/7 to the n minus 1, or I minus 1 rather, equals 57.166597. Find the limit of g sub n if it exists. So I need to find a sub 1 first. I remember that this thing has a formula which tells me that it should be equal to, okay, let's see, I've got to remember this. It should be equal to a sub 1 times 1 minus r to the 7th, all divided by 1 minus r, and that should be equal to 57.166597. So if I solve this for a sub 1, I should do 57.166597 times 1 minus 1/7 is 6/7. So times 7,